Hello everyone. So in this video, I'll be explaining you the problem all lengths subtraction. So it was asked in Codeforces Round 1051 for division 2. Actually, the power is very low, so I think the background, light is dim. So I don't know. It may, go full dim. So yeah, let's continue. You are given a permutation p of length n. You must perform exactly one operation for each integer k from 1 up to n in that order. Okay, choose a subarray of p of length exactly k and subtract 1 from every element in that subarray. Got it? Every element will have to subtract. After completing all n operations, your goal is to have all elements of the array equals to 0. So determine whether it is possible to achieve this. Got it. So definition of permutation, don't worry, I'll be telling you. And the definition of subarray, an array is subarray of array B. Got it. So of subarray definition also I'll be telling you. So for input we have test cases, and for every test case we have integer n denoting length of the permutation, and in the next line we have p1 p2 up till pn, the permutation itself. So basically output will have to print yes if it is possible to make all the elements to be 0 according to the given operation, else we need to print no. So let's take this input and understand. So we have 1 3 4 2. We have 1 3 4 2. Is it looking? Yeah, so we have length as 4 and this is a permutation. So okay, first the permutation p definition, what they are saying is that you have n length array and you have given p array as a permutation wherein your p elements will be from 1 to n and all are having only 1 times. Let's say n is equal to 5. So if you take 1 3 4 2 5, so this is one of the permutation of length array 5, because in this array if you see the length is 5 1 2 3 4 5, and from 1 to 5 all elements are occurring only one time. We have 1 2 3 4 5, and if you take 1 2 3 2 5, if you take this length is 5, but in this case if you see 2 has repeated 2 times and 4 is not occurred, so this is not a permutation, so this is permutation. Also you can consider 1 4 5. So if you take this, the array length is 3, so your element should have value between 1 to n, which is 1 to 3. So you should have value 1 comma 2 comma 3. 1 you have, but 2 3 is not there, so this is not a valid permutation. So definition of permutation I think you guys got, and let's take the definition of subarray. So subarray definition is that, let's say you have array 1 2 3 4 5. Okay, so you'll have to take subarray means continuous elements you'll have to take. So 1 2 3 is a subarray, you can say. 1 2 is also a subarray because it is continuous. 1 3 4 5 is not a subarray because 2 is kept in between, so 2 is not, this is not a subarray, this is a subarray. Also you can't take the other way, like 4 3 2 you can't take as a subarray because the order is in the array is like 2 3 4, but it is 4 3 2. The order is not present, like 2 should be before 4. Here it is like 4 is 2 is after 4, so it is not a subarray. So I think these two definitions are clear. So these two definitions are clear, let's understand what the operation they're saying. The operation what they're saying is we'll have to perform the operation from 1 to n. Basically k is equal to 1 to n, which means we'll, in every operation you will have to choose among this array whatever they are given. So among that you will have to choose the k length subarray. When you're doing the operation for the first time, k is 1. When you're doing operation for the second time, k is 2. So in that case you will have to choose the 2 length subarray, and every element of the array, every element of subarray has to be decreased by 1, subtracted by 1. So I think you guys got to know what they're saying. So in this case let's say when k is equal to 1, which means your operation will start from always k is equal to 1 to n. When k is equal to 1, here n is 4. When k is equal to 1, let's say you are choosing this as the subarray, one length subarray, and you want to decrease its value. So your subarray will look something this way, right? Because 4 has decreased to 2. Now you're doing k is equal to 2, operation k is equal to 2. So 2 means you'll have to choose 2 length subarray. So let's say you have choose this 2 length subarray. Now you want to decrease every element of that 2 minus 1. Just give me a second. So now you are choosing 2 length subarray. So every element of the subarray has to be decreased by 1. So if you decrease, that is going to be 2 and 2. So now your permutation array will look something this way. Now for k is equal to 3, you will have to perform the operation, which means 3 length subarray you will have to choose and decrease the values of subarray by 1, all the elements of the subarray by 1. So let's take this subarray as length is equal to 3. So now your array will look something 1 1 1 1, because these elements are decreased by 1, so it is 1. Now for k is equal to 4, you will have to do the operation. So take the entire array as subarray and decrease the value by 1. So now your array is going to be something 0 0 0 0. So all the values are 0 and you can achieve 0. So that is what you will have to say. Once you can achieve 0, you can print yes, or else you'll have to print no. So okay, so let's take second example and understand. First example we had as 1 3 4 2, right? Okay, this was first example wherein p was this. In the second example, p, I think so in the first example, as I said, we'll have to print yes. So in the second example, we have 15243. We have 15243. So in the second example, we have 15243. So you will have to do the operation from k is equal to 1 to n is equal to 5. 1 to n you will have to do, because here n is 5, length of the array is 5. 1 2 3 4 5. So yeah, so let's do for k is equal to 1. Let's say we are choosing this element and trying to decrease the subarray length by 1. I mean not length by 1, each element by 1. So this is going to be 4 2 4 3. Now for k is equal to 2, we'll have to choose. So okay, so in the previous example where I was explaining you, this 4 was decreased to 3 and you had continuous 2 3s, and you are decreasing these 2 3s to 2 comma 2 comma 2, and you had continuous elements and you are decreasing it by 1. So you had like all elements as 1 1 1 1 and continuously you decrease to 0 0 0. But here if you see this 4 right now, like largest element whatever you have taken, that is subtracted to 4 when k is equal to 2, like 2 subarray you are choosing which has 2 elements whose length is 2 and which should have the same all the elements in that array, but you are not having that kind of subarray in this, so it will not be possible. Let's say you take this subarray and when you try to decrease it, your values will be something this way. Now when k is equal to 3, again you will be, let's say any operation you will be doing. Let's say you're taking this, so that is going to be 0 4 3. When k is equal to 4, let's say now you want to take this, so this 0 will go to minus 1 and again like it will go negative. So you want all the elements to be 0 0 0. So in this case it will not be possible. So one of the observation is that basically in order to solve this, what we'll have to do is you will have to consider, I'll be taking first example 1 3 4 2 we had. So what we'll have to do is we'll have to consider the largest element in the permutation p. So once you take the largest element, now try to decrease this element. When you decrease this element, you have got 3. Now you will have to check its left or its right, that if that element is 3, after decreasing whatever value you are getting, same value you are having on the left side or on the right side or not. if it is there, which means 2 length subarray you have got, and now you will be taking in second operation as these elements, and you will be basically decreasing it. So basically decreasing in the sense, you had the highest element, and I'll be taking 2 pointers left and right. Okay, before taking 2 pointers, let me explain properly. So which means what I'm trying to do is, let's say you have 3 comma 3 comma 3 in this subarray. So from the definite, I mean, whatever implementation I was doing, you got to know that all the elements has to be continuous only. If there are any breaks, which means let's say you have 4 4 2 4 and 4, so in this case you can't take this 4 4 as one of the you know subarray and then decrease it. You can't do that. So continuous element has to be there. So in order to be continuous elements, so only left and right, if you take care, so middle elements will be always, you can skip off. Basically what I'm trying to say is that whenever you have taken this largest element, you decrease the element. Now you want to find the element which is having 3, so it should be beside its element only then you want to decrease it to 2, or else if the 3 is somewhere else, so in that case the other element will be decreased, and that element is going to be reduced less than 0, or it will remain more than 0, right? So let's say you had something like 1 comma 3. So if you had like 3 comma 1, so in that case you don't have the element equals to 3. So no matter you take this element, if you take this element, so this element will be decreased to 0, and in the other operation you will be having wherein your whole array you will be considering, and that time this element is going to be -1. So that is the reason you will be taking whatever element was that, 1 3 4 2. So you will be taking the highest element, and you will be decreasing this to lesser than 1. So you have decreased it. Now from this element you want to find uh, you know like the decreased value, whatever is it, that is present on the left side or right side or not. If that is present on the left side, which means now you have got these two, I mean for when I decreased for the largest element, that was k is equal to 1. So when I'm checking for the left hand side and right hand side, which means I'm taking care of k is equal to 2, and when I'm taking care of k is equal to, which means 2 subarrays I'm taking, so this 3 and this 3 are equal, so we can decrease this value. When you want to decrease this value, so your value now is going to be 2 2 2, okay, which means these two subarrays you have taken care of, I mean sorry, one subarray whose length you have taken care of. Now your idea is that you want to find from this element if you have 2 or not. This is not there, but from this element now you will be finding if 2 are there, is there or not, you have to. So what you will try to do is, for k is equal to 3, you will be taking this as the subarray. So now you will be decreasing its value. So in order to now decrease this, you have 2 is decreased to 1, and but this 2 will be as it is 2 only, we are not decreasing it while we telling you, and this 2 is decreased to 1. Since I mean like you have this as one of the subarray, right? So basically in the subarray all the elements are equal only, so only the leftmost part and rightmost part, whatever is there, that you are checking on the right hand side and the left hand side. And since these values are entire values are same only, so always left and right values will be same, and that is the value that you are trying to find it. From this one, if you try to find on the right hand side, you are not having any value, but from this if you try to find, you have 1 and which are equal. So what now you can do is, for k is equal to 4 operation, you can choose this as subarray length, and you can make these values as 0. So in that case your value is going to be 0, and this is 1 only, 2 only, 1, right? So basically what I'm trying to say is that whenever you have wherein you can make all the elements as 0, so that will always start from the maximum element. that will always give me a second, why it is getting blurred. Yeah. Now it is clear. So what I was telling, from the highest element you will find the next lowest element, so you have got that. And from these two, now you want to find the next smallest element, you have got that, which is in continuous way. Okay, and from these three you will find left hand side and right hand side and find the next smallest elements, which is you have found it. If while doing this operation, in the second case, if you take, like you have 1 5 2 4 3, so in this if you see, uh, 5 is the highest element, and now if you want to find the element lesser than that, which is 4, so you don't have not in the left hand side nor in the right hand side, so in this case it will not be possible. Let me take the third example and explain you, so that you'll be clear with this concept. So as I said, in the second example, answer is no. In third, we have 2 3 5 2 4 5 3 1. We have 2 4 5 3 1. So in this case, highest element is this. Now you want to find the next smallest element, which is 4. You have got it, 2 elements. Now you want to find the next smallest element, which is going to be 3. So from this subarray length continuous, you have found one more 3, so that is continuous only. And from this in the subarray you want to find the next smallest element, which is going to be 2, right? So we have found this. Now from this subarray you want to find the next smallest element, which is 1. So like from this continuous subarray, from left hand side, right hand side, whatever is checking, you are getting the next smallest element. So if that is the case, then in your that sub permutation is going to have all the elements at 0 at the end. So what we can do is, let's say I'll be doing for k is equal to 1 to n is equal to 5. So I'm doing for k is equal to 1. So I'll be choosing this subarray. So this is going to reduce to 4. So you have 2 4 4 3 1. Now choose k is equal to 2, which means 2 subarray. This will be choosing, that is going to be 2 3 3 3 comma 1. When you're doing for k is equal to 3 subarray length you will be choosing. You want to take that, and that you're going to reduce by 1, so it is going to be 2 2 2 2. And when k is equal to 4, which means 4 subarray length will be taking, take this and reduce, so that is going to be 1 1 1 1 1. Now when k is equal to 5, take the entire subarray and reduce by 1, that is going to be 0 0 0 0 0. So I think you guys got to know how to solve this. So I think concept you have understood, but how I'll be solving is that basically I'll be checking what is the index of the highest element. So I'll take that index as and I mean that index is I initially, and I'll be pointing my left pointer and right pointer to this. And now since this is highest element, my count next smallest, I'll be taking one variable, next smallest, which will be initialized to the, from highest you will be finding the next smallest, from 5, which will be initialized to n minus 1, which is kind of 5 minus 1 4. So from this one length subarray you are finding the next smallest element, which is 4. So this left pointer you will be checking back side if you have 4 or not. So in this case you have 4, so your left will be moving to one hand, backward, left hand side, and which means now you have 2 length subarray, and your next smallest element is going to reduce by 1, which is 3. So this is the subarray that you have, and now you want to find the next smallest element. From the left you will again try to find, in the left hand side you don't have 3. From left you will not be checking right hand side, because your left pointer will always be checking only the left elements, and your right element will be checking the right pointer will be checking the right element, because your subarray whatever you have, that I mean left and right pointer will define the values, next smallest values, not the middle ones. So right hand side, you will, when you check, you have 3, which is next smallest element, so you will move your pointer to this way. Now your next pointer will be, I mean next smallest element that you want to find is that you have 3 lengths subarray and you want to find 2. So from left you will find 2, you have found 2, so that is fine. Next smallest element that you are going to find is that 1. So from left, since there are no elements to be checked, I mean left was here, no element to be checked, so you will not check in left, but on the right hand side you will check. You have 1 in the right hand side, so your pointer will move to here. And next, whenever next smallest element is equals to 0, so we'll break out of the loop and we'll print yes. And whenever doing these steps, you will be finding left and right. So if you did not find left smallest element nor in the right smallest element, I mean right hand side the next smallest element, so in that case you will be printing it as no. So I think it is very clear now. And yeah, just try, let me code it up. So so we have test cases. So test case I have taken care of this position, and for every test case we have integer n, so I have taken integer n, and for every n we have n values, which is basically permutation. So let me take vector p of n, and I'll be taking one index which is initially 0, which means I'll be finding the index of the highest element. Okay, so what I'll be doing here is that I'll be checking if p of index is lesser than p of I, so my index will be pointing to I, which means I am finding the greatest element, right? This logic is clear, I guess. So once I found the index, highest element index, my left pointer will be pointing to that index, and right will also be pointing to index. I'll be taking next smaller element that needs to be found, which is n minus 1, and while this next smaller element is greater than 0, so we will be checking if we have elements or not. Okay, so we will be checking if L minus 1, which is greater than 0, which means whenever you are checking the right hand side, left hand side, so it should be within the bounds. So you will be checking P of L minus 1, if that is equals to next smaller element, so you have found the element, so you will decrease the left pointer, and yeah, you have decreased the left pointer. Now what you will be doing is you will be checking if right plus 1 is less than n, and p of right plus 1 is equals to next smaller element, so your right pointer will be increased by 1. So once you have found the next smaller element, so in that case you take one flag value and set it to false. Basically you take one flag value, and every time you enter into a loop you say flag is true, which means or you can say flag is false, which means you have not found the element. Okay, when you found the element you say true, we have found the element. Here also if you found the element, say true. And okay, so I can write if else also. Here we can write else, if else, not like to if, because once you have found the element you don't need to check the other end, because we have a permutation, so always all the elements are unique. So yeah, now we need to check if your flag is false, which means you have not found the element, you did not found the elements in a continuous way. So in that case your all the elements cannot be 0, so just say no and return, else you will have to decrease your next smaller element by -1, like you'll have to find the next smaller element. So once you come out of the loop and you have not once you come out of the loop, It's like all the elements are in a continuous way from the highest elements. So in that case, our answer is possible. Just say yes. So let's try to run it. Yeah, it is getting passed. Let's try to submit. Problem name is all length substring. I think system testing is going on, so this will not run. I mean, yeah, I can't submit the code, but if you do this, that is going to accept the solution. I've done in the contest, as you can see, it is accepted. So yeah, this is the code that you need to write. I think um, you know solution is very clear, like whatever I've said. So yeah, if you understood it, just like it, subscribe, and then share with your friends. Thank you guys for watching the video.